Hello again, and welcome to Operations Management. In this session, we're going to be talking about critical path. Critical path allows us to determine how long a process actually takes. So what we're going to be doing is following a process flow diagram from beginning to end, but we're also going to be taking a look at the time it takes to complete each activity. For this, we're going to use an example of cleaning an office. If you notice here, we have 6 different activities, starting with picking up things, all the way through dusting, sanitizing, vacuuming, emptying the trash can, and finally cleaning that doorknob when we leave the office. Just like before, when we did doing diagramming processes, we have precedence relationships. And this time, we're also adding times to complete individual activities. So picking up the cups and so forth takes 55 seconds, dusting the surfaces is 300 seconds, and so on. As you can see, all of those times for the different activities. So now when we build the process flow diagram, not only are we concerned with the precedence to make sure that we put the activities in order, but we're also interested in how long every activity takes. So here we have it. Starting with picking up the cups and papers at 55 seconds, activity A, we branch off into 3 different activities. B, C, and D can be done at the same time. B, dusting surfaces, takes 300 seconds. Sanitizing things, activity C, is 90 seconds. And vacuuming, activity D, is 360 seconds. Once we finish dusting and sanitizing, we can empty the trash can, E, at 40 seconds. And finally, once we finish vacuuming and emptying that trash can, we sanitize that doorknob and leave at 40 seconds. So how long is it actually taking us to complete this entire process? What we need to do is take a look at all of the different ways we can get through this process flow diagram. Notice from A, we branch off into 3 different areas, going from A to B to E to F. That's one way through the process. And if we take a look at that path and we add up all the times on the activities of that path, A, B, E, and F, that path goes and takes 435 seconds. But there's another path through. That's A, C, E, F. And if we add up the times along A, C, E, F, we end up with 225 seconds. And lastly, we have a path that's just ADF. It looks like the shortest path because there's only 3 activities on it, but in actuality, the length of time is the longest, 455 seconds. So how long does it take to get through the whole process? It's 455 seconds. That is our critical path. It's the longest path time of a process. So what it means is that by the time we finish ADF, we've also completed dusting the surfaces, sanitizing, and emptying the trash can. But what happens if activity times change? Here, activity B has been increased. We went from 300 seconds to 330 seconds. And vacuuming the carpets went down by 20 seconds from 360 to 340. Let's see what kind of impact that has on our process flow diagram and our critical path. So here we have the same diagram, but with the changed times for B and D. So let's take a look. A, B, E, F. Well, that's now 465 seconds. A, C, E, F, that didn't change at all because none of the activities on that path changed at 225 seconds. But lastly, A, D, F, that changed, and it's now 435 seconds. So because the times changed on activities, the critical path changed as well. The critical path moved from ADF to ABEF, and the process flow time changed. It went from 455 seconds to now 465 seconds. So as you can see, when you're dealing with processes and the activity times, if those times change, you have to take a good hard look at your process flow to see whether your critical path has changed as well. In our next session, we're going to be talking about slack time. Slack time says certain activities don't always have to be started right at the beginning. Sometimes they can wait a little bit. And how much time you can afford to wait? Well, that's slack. And that's what we're going to do next. See you then.